Good morning, all, and thank you for attending our webinar today. My name is Silvia Dominguez. I'm a research associate at Université Laval in Quebec, Canada. So I hope you understand that due to the time zone differences, I had to record my presentation in advance. I apologize for that. During this talk, what I will present is a methodology for converting food expenditure data from household budget surveys into food consumption data, which, as you will see as we go through the slides, can be used as a surrogate for data that is collected directly through food consumption surveys. So basically, I will describe the data transformation steps, which are several, that are needed to go from the amount a household spends, so this is expenditure, in food, to the amount of food consumed by what we call an adult male equivalent. But I will explain all that in the coming slides. So let's get started. So as I mentioned before, what we call food expenditure is basically data that is collected in household budget surveys in monetary value. So for example, in dollars or other currency that represents the amount that a given household spends in different food items in a given time frame. So for example, in a week. When food consumption data is needed, so as risk assessors, for example, we need this type of data for chemical exposure assessments or for total diet studies. The information that is collected via specialized methods like 24-hour recalls, food frequency questionnaires, etc., is of course the gold standard. There is a very well-defined and very systematic methodology for conducting this type of survey. But a robust and representative food consumption study is usually costly and very time-consuming. And not all countries have the financial or the technical capability to conduct them. Also, even if there are some countries that do have this type of data because they have conducted national food consumption surveys, for example, the data is not necessarily publicly available in its raw states. What you would find often is aggregated data, for example, mean consumption for the whole population, and that's not really what we're looking for when we do probabilistic risk assessment specifically. But on the other hand, many countries regularly conduct household budget surveys, and these are readily available. They already have them. And we can use this expenditure data, which would be quicker, would be more cost effective than directly collecting food consumption data through the type of food consumption studies that I was mentioning before. Now, we have to keep in mind the most important limitation to this approach is that expenditure will remain a surrogate for consumption because in this type of household budget survey, we will not measure directly consumption. We measure expenditure, then we transform this into consumption. So it is a surrogate, but it can provide representative estimates. So with all this in mind, and as you will see in the following slides, using data from household budget surveys is not necessarily straightforward. In terms of data requirements, the most important thing is to have access to the survey's raw data. Specifically, what I mean by raw data is the composition of each household, so the age and gender of each member of the people living in this house, and the amount that is spent in food per household. So again, we don't need, at this point, it's not what we're looking for to have aggregated results like a mean amount spent by the entire population. We want to have the amount spent in food per household. So as you can imagine, having access to this type of data is not necessarily easy, but it's likely that it is available. So we should try to exploit it. Now, apart from these two first bullet points in black, I'm listing other bullet points in green. That is information that is not coming directly from the survey itself, but we also need it for the transformation steps. And I will explain them in more detail in the rest of the presentation. You will see them in green as we go on through the slides. So I mentioned at the beginning the adult male equivalent. I will now start walking you through the data transformation steps, but this is the first concept that I'd like to introduce that is very important for this approach. So as we mentioned, a limitation of household budget surveys is that they provide expenditure data for an entire household, per household. We don't necessarily know how many people, what proportion of this expenditure corresponds to each individual in the household. So to overcome this limitation, what we can do is express household composition in terms of the energy needs of a reference individual that we will call the adult male equivalent, or as you'll see an abbreviation, the AME. So again, a household budget survey would give us an amount spent in the whole household. The household is composed of several individuals, for example, 2 adults, 2 children, 1 adolescent, etc. But we don't know which proportion of the expenditure corresponds to the consumption of each individual. So for that, I'm repeating myself, I know, but I think this is an important point. For that, we will use this adult male equivalent to be able to express expenditure in terms of a reference individual's energy needs. Okay, so an AME on adult male equivalent is based on the energy needs of an adult male. The energy needs of other age and gender groups are then expressed as fractions of this reference value. Standard energy needs per age and gender are actually available from various sources. This is some kind of information that you can find easily online. This, for example, that I'm showing here is a table from the United States that lists the estimated calorie needs per day by age, gender, and physical activity level. So if we look in the red circles at male, moderately active, at age levels between 26 and 40, we see that the estimated energy need is 2,600 kilocalories. So this could be your adult male equivalent, your reference individual, or you could also choose to use a different table. This is from the United States. Perhaps, most likely there are tables more specific to certain regions or certain countries, but keep in mind that this is just an example. So once you select the energy needs data you will use, you can build a table of adult male equivalents for all age and gender groups in your population. Your population meaning the national population or the regional population you're trying to cover with your study. So we will have, for example, different age groups, female and male. And this table is just an example, very simple. I built it to illustrate this point. You can see here that the male between 26 and 45 years old is, in this case, our other adult male equivalent. Remember from the table before, we saw 2,600 calories. We're dividing it by the exact same value because it's a reference individual, so we have 1. But then, for example, a 2-year-old boy, here, a 2-year-old boy, represents 0.38 of the adult male equivalent. So this is obtained by dividing 1,000, which is its energy needs, divided by 2,600. So this type of conversion will allow us to express the household composition, so each member of the household, in terms of standardized units. Now, as I said earlier, having access to the survey's raw data is absolutely critical. This is, again, a very simplified table where I'm listing hypothetic number of households in the first column here, and next to it, the breakdown of the household members. So this is going to be a very simple one where we again have a 2-year-old boy and 1 adult male. Okay, keep in mind these are simplified examples. So if we use the adult male equivalent from the previous slides, 2,600, this represents 0.38 for the boy and 1 for the adult male. And then we add these values. This is just a sum. And we obtain the total AME for the household. So 0.38 plus 1, and we get 1.38. And this is what we would do for every single household in the survey, in the household budget survey. So from now on, we will express the composition of each household in terms of AME. Now, the second step is much simpler. Household budget surveys track food expenditure in a specific time frame. So if the survey, for example, is based on a 2-week period, dividing the amount spent per food item per household by 14 will transform the data into a per day basis, which is what we want. So this one is quite simple. Now, those were just some preliminary steps to standardize our input, our raw data. Now we'll go through the core steps to transform our data from food expenditure into consumption, meaning this means from amount of money spent in food into amount of mass quantity. So, for example, grams or milliliters of food consumed. The first thing we need to know is the price of food in this specific country, okay? We're talking about expenditure, we're talking about money. We need to know the specific prices of every food item. This, again, is information we can obtain locally or from international organizations or databases. Here I'm listing just a few examples of sources in this side box. But something important you must note is the units that the source you selected uses to report the price of food. So it could be, for example, per grams, per 100 grams, per unit, etc. Now, to avoid mistakes, because we're getting into a lot of very specific transformations, it's recommended to build a price per food reference table. Again, in a very simplified example here, where the price per unit of each food included in the household budget survey is listed. So we have here all our food items. And in this example, you see I took data for Afghanistan. You can see the price of rice is given per 100 grams. We have a price of 9.2 Afghan currency, which I don't remember right now. But all we need to do is divide it by 100. So the unit base of our price sources. And then we'll obtain the price per gram, which is, again, what we were looking for. Okay, so with the previous steps, what we managed was to express food expenditure data reported in a household budget survey as the amount spent per household per day for each food and each household. Now we know how much each unit of food costs from what we saw before from our price tables. So obviously we can now calculate the amount of food purchased by each household by dividing the amount spent per day by the cost of a unit of food. And now we have an amount of food consumed, so a mass of in mass units. Not in currency. So you see, we went from dollars, and now we have milliliters. In this case, we're going to see it was probably liquid foods, okay, milk, let's say. But we are not finished at all. We're still at the household level and not at the individual level. We want to go to individual. Remember, this is a whole family that is living under the same place, so we don't know how much each person consumed. But we're already halfway through. We already went from currency to amount of food consumed. Yeah, so that's what I was saying. So to recapitulate, earlier, we calculated the number of adult male equivalents per household. And just now, we calculated the amount of food consumed per household per day. Now, logically, what we'll do next is use this information to estimate the amount of food consumed, so in units of mass, per adult male equivalent per day for each food and for each household. So specifically, what we need to do now is to divide the amount of each food consumed per household per day by the number of AMEs in the household. and we'll obtain the amount consumed per AME per day for each household. And now, just now, we finally have transformed expenditure data into individual food consumption data. That was our main purpose. So here we went from the household level to our reference individual level, which is the adult male equivalent for every food item and for every household. But there are still a few more adjustments that we should make to make this information as accurate as possible. As you have to always keep in mind, we're working for based on a surrogate approach, so we should try to make it as close to reality as possible. Now, in this coming slides, I'll talk about the consumption adjustments. This means that for some foods, like milk or bread, the amount consumed is pretty much equal to the amount purchased, okay? You purchase a loaf of bread that weighs 350 grams, you will eat the whole thing pretty much. But for other food items, like let's say bananas or eggs, the amount of food consumed is not necessarily the same as the amount you purchase, because there will be steps like peeling or cooking that would change this volume. So this is something that we can and that we should consider in our estimates. Now, to be honest, this is a very important step, but it may be time-consuming. We need to consider, for example, yes, the number of foods that need conversion. It may be a lot. And also we need to keep in mind that some conversion factors are available in the literature, but others may not be and may need to be determined experimentally. There may be a lot of preliminary steps here before you reach your final amount of food consumed, the amount of food consumed as consumed versus what was purchased. But let's see now how this is done with an example. So again, we have a simple example here for rice. Rice is transformed using two factors to account for, one, the presence of dirt in the raw material, and two, the amount of water gained during cooking. These two factors can be found in the scientific literature for this specific case. So after the conversion, the amount of rice per AME per day goes from 10 grams to almost 30, which is an important increase. And next to it, I have another food, this food B, where there are no conversion factors needed. So just to showcase the fact that not all foods will need all of these conversions, but when they do, we need to be careful with, for example, in this case, we took the factors from scientific literature. Rice is a very common food, but you may have local or very regional food items that have not been studied formally, so you may need to do these calculations experimentally. Now, lastly, to work only with the most representative data, we need to exclude over and under consumption values. This can be done based on the amount of energy that each estimated food consumption represents. So, for example, consumptions above a given energy threshold could be considered overconsumers, and we could filter them out. But to do this, we need to know the amount of energy per unit of food. And this is something that, again, is relatively easy to find. You can find it in food composition tables. Since the food included in the household budget survey is most likely specific to the country or region, it would be ideal to use a food consumption table including this type of food, so a regional or a national food composition table. In this example, I'm presenting Bahrain's food consumption table, which expresses energy in kilocalories per 100 grams of the edible part of the food, okay? So again, this is another step where we have to be very careful with the units. So like we did for food prices, again, to avoid mistakes in all of these conversion steps, it's recommended to create a reference table, including the energy per unit, such as kilocalories per gram, for example, for every food in the household budget survey, like the, again, very simplified example shown here, where I'm using the data from Bahrain's table. And finally, we will calculate the energy provided by every food item consumed, adapt the values, and obtain a total energy intake per AME per day, shown here in this last column. So extreme values, after adding up all the food that was ingested, extreme values would then be removed. For example, we can filter extremes that are below 1,200 kilocalories, that would be under consumers, and those above 5,100 kilocalories per day, that would be considered over consumers. But notice this is just an example, and different energy threshold values may be more adequate for local or regional studies. So again, if you see, this is some thresholds that were used in the scientific literature, but again, there may be values that are more adapted to different diets. And this is our last slide. We're almost there. What we should have as our final product after all these conversions is a table with data points that represent the amount of food consumed. In most cases, this is going to be a very large table, a very large data set, much larger than this tiny table I'm presenting here, where for every household in the survey and for every food, we will have an estimated amount consumed, so grams or milliliters or other mass units per AME per day. As I mentioned at the beginning, using food expenditure data as a surrogate for consumption is not really straightforward, as you saw through all the conversion steps. But after all these transformations, we actually have data, representative or surrogate of individual food consumption that we can actually work with. So these values can then be used, for example, for probabilistic exposure assessments for chemical, for example, or other food contaminants, since we'll have a distribution of food intake, not only one point value of an aggregated mean. We will have representative, a whole range of food intake values. And of course, we can also apply this to total diet studies, where this type of data can guide the selection of foods that should be analyzed. So with that, I would like to thank you for your attention. I know I went through several steps relatively quickly. I hope I made this step-by-step methodology as clear as possible. And again, apologies for not being there live, but I will be glad to connect by email if you have any questions. So I'm sharing my, my information here in this slide. So thank you very much.
Well, thank you. Thanks very much, Silvia, for your contribution, even if the contribution has been done remotely, and very much appreciate actually this explanation. Now, what you wanted to do through this presentation is to show that it is possible to access food consumption data that can lead even to individual data points. But of course, with some approximations, some hypotheses that are being made, but with some level of accessibility, in that these data, and particularly these economic data, tend to be made available and tend to be collected on a regular basis by the statistics departments and organizations in every country. Now, I would like to take advantage of the fact that Dr. Muaz Sana is with us, and perhaps actually ask you, Muaz, what you think of this approach, and essentially whether it is still a way that we can rely upon in conducting exposure assessments.
Yeah, good morning. Thank you for this question. Yeah, I will answer in general. For any approach that you are using, there is pros and cons. There is no perfect approach. And what the main message for my side is, when you use those methods, you need to have in mind what are the limitations and what are the different assumptions you made through the process that was well explained by the previous presenter. It is a very systematic way to do the approximation. You need to be clear with the assumption made at each step. And I think this is the beauty of this approach, that we don't need to wait 5, 10 years to start your own exposure assessment. take it as a tier approach. This is what you have today. Have an idea about the limitation. And after that, if you see that you have huge limitation, you start to move forward and to go for more appropriate data. But you need to be flexible. And the main message, know the limitation when you are using whatever approach.
Thank you very much, Moaz. And I guess actually, I think we all aspire to having, the best representation of the food consumption information on the basis of which these estimations of exposure are to be made.